Hey guys, welcome back to my channel, the MathPad, and today we're going to do some 3D Pythagoras where we'll be applying the Pythagorean theorem and the trig ratios in solving 3D shapes. So if you look at the first question, it says, the diagram shows a pyramid with a square base ABCD. All the sloping edges of the pyramid are 20 centimeter long and AC is 17 centimeters. We have to calculate the length of the height for this pyramid. So this is your basically height. And the question is asked to calculate this. So what I'm going to do is I'm going to first calculate this length. So if we call this M, which is basically the midpoint of AC. So if AC is 17, MC is going to be half of AC. So 17 over 2, which is 8.5 centimeters. That is your MC. So 8.5 over here. Now we have to find the height. So as you can see, this is a right angle triangle. We have a right angle over here at M. So we can easily apply Pythagoras to calculate the value of the height, which is basically represented by Vm. What I'm going to do is I'm going to do 20 square equals to Vm square, or height square, plus 8.5 square. So I'm going to do 20 square times 8.5 square equals to height square. So if we calculate this, that gives us 327.75, and then we will take the square root on both sides. So square root of 327.75 equals 18.1 centimeters. So that is your value of height. Then if we go to the next question, question number 2 says the diagram shows a rectangular playground ABCD on horizontal ground. A vertical flagpole CF, which is 6 meters high, stands in corner C. AB is 18 meters and BC is 15 meters. Calculate the angle of elevation of F from A, which is basically connect these 2 points it's talking about, and see, connect these 2 points. Now we have a right angle triangle because this FC is vertical, and this is the angle that they're talking about. This is what you need to find. So in order to find this angle first, we need to find the length of AC. As you can see, these are at right angles, so that means B and D are also at right angles. And we can use Pythagoras to calculate AC. So AC square equals to 18 square plus 15 square, which would equal to 549. And then we take the square root of 549. And that gives us 23.4 meters. Now we have to calculate the angles. So we have FC. So AC acts as the adjacent and FC acts as the opposite, which means we can use tangent. Tan theta equals to FC over AC. FC is 6, AC is 23.4. Theta equals to tan inverse of 6 divided by 23.4. So we plug this in the calculator, and that gives us, and that equals to 14.4 degrees. That is your angle of elevation. And if you look at the next question says the diagram shows a pyramid on a square ABCD with diagonals AC and BD of length 8 centimeters. centimeters. AC and BD meet at M, and the vertex is at P of the pyramid, which is vertically above M. The sloping edges of the pyramids are of length 6 centimeters. We have to calculate the perpendicular height PM, and we have to calculate the angle between a sloping edge and the base of the pyramid. So first, to calculate the height of PM, what I'm going to do is you can easily use Pythagoras, this right angle triangle. It's going to be 6 square equals to 8 square plus 4 square. 36 minus 14 square. And then we do square root of 22, which basically would equal to 4.69 or 4.7. Then part B was asking us to calculate the angle between a sloping edge and the base of the pyramid. We can use the same measurements. And so I always advise that whenever you have whenever you're trying to find angles and some information is given while some isn't, always try to use the given information. So just because in case if your part A is incorrect, your part B can still be correct if you're using the right values. So since we have the hypotenuse and the adjacent, we can use cos. Cos theta equals to 4 over 6. Theta equals to cos inverse of 4 by 6. Plug this in the calculator. And we have 48.2. Now, we could have gotten the same answer if we had used tangent or sine. But in case of tangent and sine, we would have been using PM, which is an unknown that we calculate in part A. Just to avoid making a mistake and getting the second part correct, in case got the first part wrong, just go with the information that's given. So that's your angle and that's the length. Then the next question, it's asking to have a pyramid again, and they have given us the length of the square base. They have given us the length of the height. They want us to calculate the length of the edge PB. So now they want us to find this. So in this case, and we don't have the lengths of DB and AC. So what we can do is first we can find the length of the diagonal. Since this is 8, this is 8, we can use Pythagoras again, the square base. So it's going to be AC square equals to 8 square plus 8 square, which is 64 plus 64, square root of 108. Sorry, not 108, 128. And that equals to 11.3. Now we divide 11.3 by 2 to get the value of either AM, MC, or MB, or DB, or DM, because it's all going to be the same. So to find MB, since that is our focus at the moment, we do AC divided by 2. And 11.3 divided by 2 gives us 5.65 centimeters. So to find PB, apply Pythagoras again, PB square equals to 5 square plus 5.65 square So this equals to 5.65 squared plus 25 is 56.9225. And then we take the square root on both sides. And that gives us 7.54. That is PB. Then in part B, it says the angle between PB and the base ABCD. 7.54. And wait, this was 5.6. Let's find the angle that we're making over here. So what I'm going to do is I can use tangent. I can use actually either of the ratios, but I'm going to go with tangent because that's going to use the given information as well. Tan theta equals to 5 over 5.65. And then we do tan inverse of 5 over 5.65. So that's going to give us 41.5. That is the angle that your length, your slope PB is making with the base. If you have any questions or confusions about any of these, just let me know in the comments below and I'll help you out.